So after doing inverses of linear functions, let's start the inverse of quadratic functions. So let's say the function is equal to x squared, and here we must again have a recap on the validity of functions. We know that functions are valid only when the function is a one-to-one function, or the function is a many-to-one function, and the function is not valid when it's a one-to-many function, meaning I have three types of functions. One is one-to-many, where the values are all, one-to-one, where the values are all unique. And for this type of function, we said that it could be a linear graph here. Then we said a many-to-one function, that also is a unique function, and for that we discussed the example of a quadratic function, where we said that, let's say this is the quadratic function that we have. Then for this quadratic function, each and every value of x is again having a unique value of y. But for many, these two, they are valid functions. But if we have many to one function, then one to many function. If we have one to many function, then one to many function will not fall in the category of functions. So why? Because we said that a single value of x cannot have two values of the function. Like for this parabola here, I can see that one x value is giving me two y values. It's y1 and it's y2. Such kind of parabolas or one-to-many functions do not fall in the category of functions. The function definition is not valid for one-to-many functions here. So this is the recap required to understand the inverse of quadratic functions. Let's say that we have a simple basic function which is y equals x squared. Then for this function which is y equals x squared, I know that this is the function which should be passing through the origin. The x-intercept is a 0, and it's the curve with a minimum turning point. This is how the curve shall be. This is the curve for y equals x squared with respect to the origin, the x-axis and the y-axis. Now y equals x squared, yes, it is a valid function because I can see that each and every function x value is giving me a unique y value. It's a many-to-one function, so yes, it's a valid function. But let's say I have to get the inverse of this function, which is y equals to x squared. For that, I will be dividing it into two parts. And for the inverse, we know that it has to be the reflection in the x-axis. In the first part, I am considering the values of x which are lesser or equal to 0. So if I reflect it in the line which is y equals x, I can see that the reflection of this line has to go this way. The reflection of this line has to go like this. So we have fx, which is x is lesser or equal to 0, and we have f inverse x also. And for both of them, I can see that x lesser or equal to 0 is the domain. Therefore, the inverse function, for the function inverse, I am having the domain for f inverse. I am having the domain which is x to be greater or equal to 0, and I'm having the range which is f of x lesser or equal to 0. If I look at the function itself, then for the function I could see that the domain was x lesser or equal to 0, and I can see that all the y values, they are increasing from the origin. Therefore, f of x is greater or equal to 0. We know that when we get the inverse, the domain and the range, they get interchanged, they get swapped. That means the x values become the y values and the y values become the x values. We can see that point getting confirmed very much here. Function domain x lesser or equal to 0, that is in the range of the function which is fx lesser or equal to 0. The range of the function was fx greater or equal to 0, and I can see here that for the inverse, the domain is x greater or equal to 0. So therefore, the inverse is perfect. We have gotten the domain also, we have gotten the range also, and we have drawn the inverse function as well. Now so for the other part, which defines the function domain as x to be greater or equal to 0, I have sketched the graph for x greater or equal to 0, and the reflection in the line y equals x to get the inverse function is also drawn here. So I have obtained the two curves. The sketches, they are just the sketches, so they are exaggerated, but this is how approximately their inverses are going to be. Let's discuss the domain and range of the function and the inverse. So for the function, what I have seen is that for this part, the second part where x is greater or equal to 0, the domain is greater or equal to 0, and the range is also greater or equal to 0 here. And if I look at the function inverse, then for the function inverse, again I can see that the domain is greater or equal to 0, and the range of the inverse function is also greater or equal to 0 here. So both the domain and the range conditions, they are also getting verified. Now, if I give you the complete sketch of y equals x squared, and I tell you to get the inverse function, then let's see what happens there. So what happens is that if I combine the two inverses, number one, for x lesser or equal to 0, I could see that the part of the inverse function which I got was basically the part of the inverse function which I got was this kind of parabola. This was the inverse function when our x was lesser or equal to 0, when the domain of the function was lesser or equal to 0. And the function inverse for x to be greater or equal to 0 was of this shape. So if I combine the two, what I can see is that this function here is giving me the function which is one-to-many. So one-to-many function that does not fall in the category of the function. I can see that there are two values of y corresponding to one value of x. So such functions, they are not possible. So that means the inverse of a quadratic function is not possible there. But we are going to divide, but we have seen that if we have divided it into two separate parts, from the turning point, two separate parts, one was x lesser or equal to 0 and the other was x greater or equal to 0, we were getting the two functions which were unique. They were both one-to-one functions. I can see that both of them, they are giving me one-to-one functions here. This was one-to-one, this was one-to-one. All the values here, they were one-to-one. So that means the quadratic function, which was actually many-to-one, quadratic function, which is actually many to one, when divided into two separate parts from the turning points, I can see that they give us the inverse function which is one to many. Both of them, they are giving inverse functions which are one to many. That means we can have the inverse only if the quadratic curve is divided from the turning point. But if we take both parts and having the turning point in between to get the inverse, then the function becomes one to many, which will not be valid for the function definition. So always, whenever a quadratic equation is given to us, we have to divide it from the turning point, or in other words, we can say that we can consider either parts of the turning point to get the inverse of that function. So let's do an example to consider, to get the explanation of what this all means. Let's say the function fx is x squared minus 6x plus 2, and this is defined for the domain which is 0 lesser or equal to x lesser or equal to 3. So part A, express the function f of x in the form a in the form x plus a the whole square So x plus a the whole square, to get the solution, we know that the question is asking for completing the square method. And for that, if this is x square minus 6x, I need to divide 6 by 2, which will give me a 3. So I will be adding 3 the whole square and then subtracting 3 the whole square as well. So subtracting 3 the whole square as well. And my answer then shall be the first three terms with the middle sign as negative. It should be x minus 3 the whole square plus 2 minus 9, or I can say that this is x minus 3 the whole square and a minus 7. So this is the function value that I have, and from here I know that I should be considering the turning point, which is 3 and a negative 7. Now just consider the domain, which is 0 lesser or equal to x, which is lesser or equal to 3. So starting from the origin, if I just sketch the curve, it's very helpful to sketch the curve always, because that is going to give us a very clear picture of what is happening for the given function. I know that my y-intercept is a 2. The y-intercept given in the question, that was a 2 here. So it's easy to have the y-intercept there. The function is of minimum nature, and so from 0 till 3, I can see that obviously the curve was supposed to have a being a quadratic nature. This is how it was supposed to be. We got the turning point, which is 3 and negative 7. And because I need to have the domain from 0 to 3, then the only part of the curve that I should be considering is from 2 up till negative 7. So this is the part of the curve that I should be considering here. That should be within the given domain. Now, if I look at the domain here, it's from 0 to 3. And if I look at the range values, then I can see here that the minimum range value is a negative 7, and the maximum that we can go for is a 2. So the range can be given as a negative 7, which is lesser or equal to the function fx, which is lesser or equal to 2. So with the help of the domain, once we have the turning point and once I have sketched the curve, I can very easily get the domain also. So the second part of the question said to find the domain. So part B, state the range of f. State the range of f that we have very easily found with respect to the curve that we sketched, and we know that this range is from negative 7 lesser or equal to f of x, which is lesser or equal to 2. Now the third part of the question, state the domain of f inverse. Now to state the domain of f inverse, we know that for the inverse function, the range and the domain, they just get interchanged. They just get flipped, or they just get swapped. So if I have the domain of the function, I have the range of the function as well. So for the function, if I just write them for the function, then for the function, the domain was from 0 till 3, 0 lesser or equal to x, lesser or equal to 3, and the range of the function was from negative 7 lesser or equal to f of x lesser or equal to 3. Then for the range, for the inverse function, I should say that the domain of f inverse will be actually the range. Therefore, I'll just write it as minus 7 lesser or equal to x lesser or equal to 3, and the range of f inverse If asked, that would have been from 0 lesser or equal to f inverse x, which is lesser or equal to 3. Sorry, the domain was up till 2. So this is how it's going to be. Now the question, now even if I need to sketch the curve, then what I will do is if I need to sketch the curve, then what I should have done is I should have said or considered that I should have considered the fact here that the inverse of the function shall be, it's 0. There are 2 points. One was the y-intercept, which is 0 and 2. That means I'm having the x value for, let's make it with a different color, x value, which is a 2 comma 0. I have just swapped 0 comma 2 on the x-axis as 2 comma 0. I got the turning point as 3 comma negative 7. So I will just take it to negative 7 and a 3, again swapping them. So negative 7 and a 3. And what I have seen here is that the inverse is actually going to be this shape. The inverse function should actually be having this shape here. So this graph is going to be the inverse graph here. So now if they say for part D, find an expression for f inverse. So to find an expression for f inverse, part D, so find an expression for f inverse. We know that the function is x squared minus 6x plus 2. We have expressed it in the completing squared form, and that was x minus 3 the whole square and a minus 7. So x minus 3 the whole square and a minus 7 was the completed squared form, and we will be taking help from this completed squared form to get the inverse function. So this means it's y, which is equals to x minus 3 the whole square and a minus 7. I have to make x the subject to get the inverse function. So to do that, I've taken negative 7 on the left side so that this becomes a plus 7, which will be equal to x minus 3. To eliminate the square, I will be taking under root on both the sides. And once I take under root on both the sides, I will be writing the equation with a plus and a minus. So it's going to be plus minus under root y plus 7 is equals to x minus 3. X minus 3 taken on the right becomes a positive 3. So this is 3 plus minus under root y plus 7, which is equals to x. So this is the inverse expression that I have at the moment. So that this is f inverse, which equals 3 plus minus under root x plus 7. Again repeating, x and y, they are getting swapped. They are getting interchanged. Now is the time to decide between the two signs, plus and a minus. For that, I will be taking help of the sketch that we just drew in the previous part. So what I can see in the inverse function is that the inverse function is actually a decreasing function. The y values here, they are decreasing. It's a decreasing function. It's a decreasing function. So if it is a decreasing function, then obviously we shall know that the sign should be a negative, because negative is always a decreasing function, so that f inverse should be equal to 3 minus under root x plus 7 here. And obviously the domain of the function, if I'm asked to get the domain of the function, then I should say that this is for the domain which is from negative 7 lesser or equal to x, which is lesser or equal to 2. This is how we will be defining the inverse function here. So next part, let's go for the composite part also. Let's say that it says express f and f inverse x in terms of x. So we have f, we got the function, and the function that we had was for the function was x minus 3 the whole square minus 7. The function was x minus 3 the whole square minus 7. We got the inverse function. The inverse function was 3 minus under root x plus 7. So if I have to have f and f inverse, then it means that in place of x, I will be substituting the inverse function, which is 3 minus under root x plus 7, and then I will be having a minus 3, and this is all to the power square minus 7. So I can see that the 3 and the minus 3, they get simplified, and I will be left here with negative under root x plus 7 the whole square and a minus 7. That means negative becomes a positive, and I will be left with only x plus 7 and a minus 7. The 7 also gets simplified, and what I can see here is the composite function f inverse shall be equal to x only. So just remember that f and f inverse, the composite function, it's always the same as x. So this is always going to be the result for the composite function f and f inverse. So let's do this question which says the function, and this has been taken from past papers. So the function f is defined by f of x, which is equals to 2x square minus 8x plus 11, and this is for x belonging to all real numbers. So part 1 says express fx in the form a bracket x plus b the whole square and a plus c, where a, b and c are constants. So to start working on it, I should say that my fx can be equal to, I will be taking 2 common, so that I am left with x square minus 4x and a plus 11 by 2 here. So I need to convert it to the completed squared form. So I will be dividing this 4 by 2, giving me the answer as a 2. Therefore, I should be adding 2 the whole square as well as subtracting 2 the whole square to the equation. So f of x then becomes 2 common, and here I will be left with x minus sign of the middle term 2 the whole square plus 11 by 2 and a minus 4. So that would give me the answer as 2 and x minus 2 the whole square plus 11 by 2 minus 4, that would give me a 3 by 2. Then I can simplify this equation with the 2 that we have taken out common in the beginning, so that I'll say this is 2 bracket x minus 2 the whole square plus 2 times 3 by 2. The 2 gets simplified here. Therefore, I should say that in completed squared form, the answers are going to be 2x minus 2 the whole square and a plus 3. So this is going to be my fx here. So this is the fx that the question asked us for. Now the second part of the question. The second part of the question said, state the range of f. So to state the range of f, I will be considering the turning point coordinates. Part of the question states, state the range of f. So to find the range of f, it's just a 1-mark question. I have gotten my function in completed squared form from where I can see that the turning point is 2, 3. It's a minimum quadratic curve with the turning point 2, 3. So what I can see is that the range is the minimum value having as 3, and I can say here that fx needs to be greater or equal to 3 for all real values. It's just an open-ended question. Therefore, the range is also going to be open. So it's fx greater or equal to 3. So this is going to be the answer for the second part here. Now let's consider the third part. Explain why f does not have an inverse. Now that's a very good question. Explain why f does not have an inverse. So x does not have an inverse because I can see that x belongs to all real values. And again, if we go back to the explanation, we are not defining it with respect to the turning point. We are considering all the domain values or the real values of the domain x belonging to R. Therefore, for the inverse, the function will not be one-to-one. So we'll simply say the function is not a one-to-one function for the inverse. For the inverse function, it's not going to be a one-to-one function, or answer could have been it's a one-to-many function. One-to-many function. Therefore, the F inverse is not possible. So giving either of the two definitions, either you say that it is not a one-to-one function, or you say that it's one-to-many function, that clearly defines that the inverse is not going to be possible here. So the fourth part, the function g is defined by 2x squared minus 8x plus 11 for x to be lesser or equal to a. It's gx 2x squared minus 8x plus 11 for x to be lesser or equal to a, where a is a constant. State the largest value of a for which g has an inverse. Now initially they said that x belongs to R, but now they have changed the condition and now they are saying that it's the same function 2x squared minus 8x plus 11, but in the beginning we had the condition for x belonging to R, real numbers, but now it has the domain which says it's x lesser or equal to a, and we need to have the largest value of a. We need to have the largest value of a for which g has an inverse. So for that case, what I can do is, so for the largest value of k for which g has an inverse, if I just look at the graph that we drew for the inverse function, we said that the graph has to be of minimum nature. And now we want x to be lesser or equal to a. That means if the graph was having the turning point as 2 and a 3, then with 2 and a 3, for x to be lesser or equal to a so that the inverse is valid, I know I have to break it at the turning point. Therefore, I can say here that the largest value should have been x to be lesser or equal to 2. That means it's just the left side of the graph that I should have been considering here. It's just the left side of the graph that I should have been considering here. It's just this part of the graph that I should have been considering here, with the x coordinate as 2 and the y coordinate as 3. So for the fourth part, my answer is just going to be that for x lesser or equal to a, my answer should have been x to be lesser or equal to 2 for the inverse to be possible. Now, when a has this value, obtain an expression in terms of x for g inverse x and state the range of g inverse x also. All right, so if I have this value, now let's sketch the graph properly to understand the sign of the inverse function. So the graph of the function can be made with respect to the values that we had for a, and we said that the values of a should be a 2 from part 4. Therefore, if this value is a 2, then we know that we should be defining the graph for x to be lesser or equal to a, meaning it is for x to be lesser or equal to 2 here. So if x is lesser or equal to 2, we already know that the function gx, which is 2x squared minus 8x plus 11 for x to be lesser or equal to 2, can also be written as 2 bracket x minus 2 the whole square and a plus 3. Meaning from here I know that the turning point is 2 and a 3. So if I sketch the graph here, it's important to sketch the graph so that the understanding gets more clear regarding the inverse function. So if I sketch the graph here, the first thing to have the inverse function is to have the line which is y is equals to x. So this is the line which is y equals x. The turning point of the graph is 2 and a 3. So let's say this point lies here, and the y-intercept of the graph of the function gx is 2x squared minus 8x plus 11. The y-intercept is a 3, meaning this is how the curve shall be, with the turning point as 2 comma 3. This is the part of the curve that we shall be observing here. So if I have to make the inverse of the graph gx, then we know that the coordinates, they have to get flipped, meaning if they get flipped, then 2 3 becomes 3 comma 2 and 0 11 becomes 11 comma 0, meaning this is how the graph shall be passing through 11 here. So this is going to be the inverse graph of gx. So to get the equation of the inverse graph, we know that the gx is equals to 2 bracket x minus 2 the whole square and a plus 3. I will be equating it to y, so that this becomes 2 bracket x minus 2 the whole square plus 3, or I can say this is y minus 3, which is equals to 2 bracket x minus 2 the whole square, or it is y minus 3 divided by 2, which is equals to x minus 2 the whole square. Take under root on both the sides. If I do that, I will be having a positive and a negative sign, meaning this is going to be y minus 3 divided by 2 under root with a plus and a minus, and this is equals to x minus 2 here, or making x the subject, I should say this is 2 plus minus under root y minus 3 divided by 2. Now how to decide between the sign of plus and a minus? Now what I can see here is that the domain of the function starts, of the inverse function, starts from 3 and it just moves on. It just keeps on increasing. It's moving towards the right. It's increasing value. Therefore, for the G inverse, I should say that the domain is x is greater or equal to 3 here. That's pretty much common here common to understand. Now, for the range of the function, what I know is that the y values, they are decreasing, so that I can say that my G inverse is going to be less than 2 here, lesser or equal to 2 here, because x was lesser or equal to 2 on the for the domain of the function, which was x less to be lesser or equal to a. So I have the range, I have the domain of the function, and what I can see here is that the function values, they are going to be decreasing from 2, so that the G inverse has to be lesser or equal to 2. So with respect to the decreasing values of the function G inverse, I should be going with the negative sign, saying that my x shall be equal to 2 minus under root y minus 3 divided by 2, or just flipping x and y for the inverse function, I can say it's G inverse of x, which shall be equal to 2 minus under root x minus 3 divided by 2 here. And this shall be defined for the domain, which is for x to be greater or equal to 3, and for the range, so that it's G inverse of x, which should be lesser or equal to 2 here. So this is what my answer is going to be with respect to the question. G inverse and they have asked for the range also.